So in the objective, it talked about a right triangle. Okay, so a right triangle. Let's try to make that line a little straighter. I don't know. I'm going to pretend like that's a straight line. And then this is a straight line. Okay? Well, you make a triangle out of this, of course. And if those lines were straight, this would look a lot better. But you're going to end up with what we call a right angle right here. Okay? Now, it's usually given this mark. A right angle is where that angle is 90 degrees. Why do they call it a right angle? I don't actually know, but I also actually don't care. That's just what it's called, okay? So this is a right triangle, and we're only concerned about that one angle being 90 degrees. That is how we will know that it's a right triangle. Now there's different words or different labels or parts of this right triangle, which is a very specific type of triangle. And they got the two sides that make up that right angle right there in orange. That's the red side, and what I have here is the purple side. Okay? The red side is what we call a leg. The purple side is what we call also a leg. These two are legs. Why are they legs? I don't know. It was made, that decision was made long before I ever existed. So, the third side of this triangle is this is the long side right here. This is what we call the hypotenuse. Why is it called the hypotenuse? I don't know. I kind of assume it's Greek for the longest side of a right triangle, but I actually don't know that. So hypotenuse is the longest side of a right triangle. It's also the side length here that I've shown in green, but you see that that side length does not make up the right angle. Only two of those sides will make up the right angle. Those two are legs. The other side is the hypotenuse, and again, the hypotenuse is the longest side of a right triangle. So why is this important? Well, it's because of the Pythagorean theorem. Okay, so let's take this stuff and look at it on the next. All right, so this is the Pythagorean theorem. It states, it's a conditional statement, by the way. If you have a right triangle, like this one we have right here, then you take one of the legs and raise it to the power of 2. And if you took the other leg and raised it to the power of 2 and added those, you'd have the hypotenuse to the power of 2. So this would be stated as leg squared plus leg squared equals the hypotenuse squared. And that's actually, excuse me, that's pretty literal. So if you actually made squares out of those side lengths, the purple square and the red square areas would add up to the area of the hypotenuse as a squared. So you'll see it more like this later on. A squared plus b squared equals c squared. It's a pretty common math term that's used, and people look at it as though it's kind of nerdy, but trust me, it's not even close to the nerdiest thing that math people do. Okay? So, you're going to take these lengths, you'd square them, the red and purple ones, and if you squared the hypotenuse length, then adding those two together would equal the same as the hypotenuse as a squared. Yeah, in this formula right here, A is a leg, B is a leg, and C is the hypotenuse. Unfortunately, you kind of have to remember that as well. So yeah, this is a key part of our statements that we're making, is that when you see a right triangle, and let's say they don't give you a picture, but they say it's a right triangle, the longest side is always the hypotenuse. All right, here's our first example. Okay, and here's what we know. That leg to the power of 2 plus leg to the power of 2 equals hypotenuse to the power of 2, right? Now, of course, you could show it as a squared plus b squared equals c squared, and in fact, they're using the c. And if you see it like this, then usually we should know that the c is the hypotenuse. But we can see also that it's not making up that 90-degree angle right there either, so we should know that it's the hypotenuse, just based on what we know about right triangles. So, we have two legs. This first one here, 3, that's a leg, so I replace the leg with 3. The other leg here is 4, so I replace that with 4. Now what I'm going to do is I'm going to square both of those, add them together, and it will equal c to the power of 2 as well, because c is the hypotenuse. So this sets up the formula that all we got to do to solve for c is just, well, solve this equation. So we'd say in my calculator I'd do 3 times 3, which is old 9er. And then I'd do 4 times 4, which is 16. Well, why didn't I add 3 plus 4 first? It's because of the order of operations. You got to do exponents first. And then I would add these two together, 9 plus 16, and I would know that it would be the same as the hypotenuse to the power of 2. And then from here, I'd say, well, 9 plus 16, that actually is 25, which equals the hypotenuse to the power of 2. So, like I was saying before, this 25 right here is the area of a square, but what we want is the side length on that, okay? So if the square had an area of 25 square units, then if we wanted the side length, like we've seen before, I would square root the c to the power of 2. But if I do it to one side, I got to do the other side. And what I end up here with is c, the hypotenuse. The square root of 25, we can put that in the calculator. Just push second x to the power of 2. And then type your 25 in there, then push enter. Now I don't really need it because I'm just looking at the posters. And I can see that 5 to the power of 2 is 25. So working backwards, that means that the side length would be 5. So I see now that the length of the hypotenuse on this one is 5. So we can even put it up here. Now this is interesting because you'll notice that there are no decimals for any of the 3 side lengths. These are all whole values. When this happens, we call these Pythagorean triples. So you'll see that vocabulary on the assignment today. Okay, so Pythagorean triple is where the values don't have decimals that repeat or terminate, or you could also see them that they do not have square roots in the answers. Which is, I don't know, it's pretty convenient. By the way, I believe on the assignment you're going to have to be able to simplify square roots as well. But we've done that before. I think it was the first lesson in this unit.